you. Forgive my jet-laggedness. I just came in last night. So I thought, instead of just talking about data centers, I'd talk about why we exist and what's driving all this, the macro trends. For those of you who don't know EdgeConneX, we've been around about 7-8 years, and the last 4 and a half, we pivoted into the data center market. And in that time, we grew from 0 data centers to 31 across North America and Europe. And if we come back and do this this time next year, there'll be another dozen under our belt. So we believe in the edge. We actually trademarked Edge Data Center 4.5 years ago, so we'll be sending out cease and desists shortly. But let's talk about why all this exists here. So we're living in exponential times, and as a species, we're used to thinking in linear terms. We're very used to thinking in what affects us within about 2 days' walk. We see a global news stream coming to us all the time. But actually what affects us is only what happens locally. So if you see something in your local town, then you think, oh, that's more relevant. You have more of a visceral response to it. But we're living in truly exponential times. If we think if I were to take 30 linear steps, I'd be at the back of the room. But if I were to take 30 exponential steps, I'd be on the other side of the moon, to put that in perspective. And if we just look at how quickly things are changing, within, 6,000 years ago, we started the industrial, or the agricultural revolution, sorry. Shouldn't have drunk before, I should have been something before I drank with that wine before we did this. Anyway, it makes it more fun. It took us about 8,000 years to the industrial revolution, but then it was a very short leap to the light bulb, and there's a huge debate, I've in America, and there's a huge debate as to who invented the light bulb. I know it was a British invention, but moving on. Very shortly after that, we were sending men to the moon. And then around this sort of time, 2011 to now, we've got AIs that are beating grand chess masters, both chess and Go. Now we're on the verge of domestic space travel. That's just around the corner. We have 3D printing that's available in the home. Things are changing very, very, very quickly in all this time frame. Now, if we were to look at the technology underpinning a lot of this, and you see this chart here momentarily, there we go. I did a quick pan here, and these dots here show how many transactions for $1,000. It could be €1,000, it could be £1,000. It's all very comparable. And you see it over there. The Pentium 2. You remember the Pentium 2? The floating points that with some issues there. So if we were to scale that, the processing complexity of those chipsets against the synaptic network of a brain. Around the Pentium 2, we were about the same sort of brain power as an insect. So for $1,000, you could get the sort of brain capacity of an insect back in a few years back. Now we're about the small mammal. If we take that further here, we should be around this, for $1,000, you can go and buy the capacity or the complexity, the technology of a human brain. Now this was a beautiful curve until NVIDIA brought out this new GPU chipset, which has really screwed things up for me. So I really have to rescale this. So I think we're actually going to be there a lot quicker. Particularly, you see what they're doing with a lot of GPUs put together for Bitcoin and the underpinnings of all those structures. And now there's a lot of complex compute that's going on just on GPUs, which is sort of taken away from the traditional Intel-style chipset, the ARM chipset, and the RISC chipsets. But anyway, if we keep this going forward, by the time we get just a few years out, about I think it's going to be more like 2030, 2040, for $1,000, if PC World and in the States, if Best Buy still exists, if Amazon hasn't destroyed all that commercial market, you'll be able to go and buy something akin to this, which will have the capacity of all the brains on the planet. And when you think about how the connectivity is going, that's a fascinating concept. So we have this whole digital transformation process, and I like to use this as an analogy. If you look back a few years ago, most compute was sort of in-house. We build buildings to hold these computers, these single entities, from Burroughs and Unisys and ICL and IBM. And it was really this structure here, and we measured everything in kilobytes. Remember those massive floppy disks and the massive drives? Maybe I'm just too old and dating myself. But this was anywhere between 67 and 92 pre-internet era. So 1992, that's probably me, I apologize. I thought I turned that off. So this was the pre-internet era. This was prior to the High Performance Computing Act, which made commercial activity on the internet feasible and permissible. And then around that time, you had the PC, the IBMs, the Compaqs, the Dells, and we started measuring things in megabytes. That took us to a whole new type of compute structure, where we had more the in-house data centers were being transitioned to PC servers running Novell and Banyan and Linux and LAN Manager, LAN Server. And a whole new group of companies came on the scene there. And this took us to this first wave of transformation, to about the year 2000. And then, by that time, we were really measuring things in gigabytes, which took us then to the online era, which was the advent of Amazon, Google, all of these companies here. And we started moving our computer devices to purpose-built structures again. And in many cases, it was the reformed data center buildings that were just restructured, and a bit more cooling put in there, a bit more power. And that was really the launch of the data center era. So that's really the second wave of transformation. And then we started measuring things into terabytes. And now we get to where we are in this era here, which is where the cloud came in. Once we started doing virtualization of these systems, we started having disaggregation of the application sets, the workflows could be more mobile. Then we have a whole new bunch of systems coming up there, and programs and applications and companies. And that's really the third wave of transformation, which is now the zettabyte. I can say zettabyte rather than zettabyte. So if I start using Americanisms, just raise your hand and give me a slap. And this is fascinating. So we produce about 2.5 quintillion bytes of data a day. That's 18 zeros. That's a huge amount of data. But in actuality, we only actually look at 0.05% of that. So there's an awful lot of data that's either just being got rid of. Well, you imagine. So if those of you have hard drives, you fill them up to capacity, you then go to a Google Drive or an Azure Drive or an Apple Drive, whatever. As soon as you get to a gig, you probably take a gigabyte. When you get to that 800, you're 80% full, you start getting emails, you think, oh, I should do some housekeeping. Well, how much is it to add another gig? Then you just do that, or a terabyte. So we're terrible at doing our own housekeeping. So this data is just going out of all proportion. Now let's look at some of the drivers there, internet access. And if we go back to where we started as an industry, we were helping companies light buildings. I realize that's the American version, so I apologize for that. But a lot of companies wanted to bring Ethernet into the buildings to sell services to those businesses within them, and that's where we started. So when we measured those in amps, we were just doing little boxes in the building to get network access into the building. So that was around this time here, up to about 2012, 2 to 5 amps. That's how we measured things. And then we started seeing how content needed to be closer to the users, because frankly, Netflix was crushing the backbones for most of the providers, and there was a necessity to move those caches much, much closer. And this was the advent of what we now know as Edge. It was taking that content, that peering, all of the data flow, and moving as close as possible to those companies, or to those metro markets. And then we measured them in megawatts. So it's 2 to 8 megawatts. That was an edge data center. Very different from the peering and the core node networks in the core. So from here on in, we've noticed that we've moved on from content. Cloud is now becoming the predominant way where people move their workflows. Microsoft made a huge shift in their sales structure, where they were incenting their sales team to sell access to Office 365 and Azure instead of the CALs. So a lot of enterprises have moved to the Microsoft cloud systems, which was wonderful for them. And then they realized that latency was becoming an issue, because over the years, the large hyperscalers had started to build their own data centers where land and power was cheap, which was a long way away from where most of the people were using. They go accessing that data. So then latency becomes an issue. So we're seeing now a requirement for those hyperscalers to build smaller instances of their cloud nodes. And by small, 20 megawatts is small, as opposed to 100, 200 megawatt site. So those are now the new edge of the network, the new edge of the cloud. And those are, say, 20 to 60 megawatt sites. Now, as we move forward, and there's a lot of work being done by many, many companies across North America and Europe to ratify 5G, and obviously this is going to be the nirvana of everything, and I'll talk about that shortly. Now we're seeing the need for multiple antennas everywhere. As Giles said, we'll have these mini data centers absolutely everywhere. And here, we're measuring these now in, again, 2 to 5 amps, so there's going to be thousands of millions of these. The wonderful thing about 5G is the ability to have vast amounts of data transfer, but the throw is very, very short, so you have many, many more antennas. But again, all of that has to be aggregated back. So we're sort of going full circle from where the edge of the internet is. So the edge is everywhere. For us, we define the edge as the lowest latency point between the service and the consumption, irrespective of what that service and consumption is. So if it's a piece of content that has to be delivered to a house over broadband, then the edge is the closest point to the broadband company's head end. If it's a cloud service, then that edge might be within the region. It might be within the London region, the Manchester region, the Chicago region, the Santa Clara region. It's very much the point where that can be handed off. And we're not replacing the core, but it's just moving the workflows and those abilities to access it as close as possible. Now, within the next 18 to 24 months, depending on ratification, you'll see the edge will now be on a lamppost outside. It could be within this building here. A lot of buildings have Wi-Fi. They've spent a lot of time and effort putting Wi-Fi, flooding Wi-Fi into the buildings. And with some of the technologies that 5G will deliver and some of the back-end processes, it's giving a lot of the telephone companies the ability to leverage that, to enable structures like this building here. They could start doing the handoff from your cell phone to a Wi-Fi signal. So it enables 5G to transition, and 5G over IP and Ethernet to move around. So the edge is going to be constantly shifting process. The edge could be an autonomous vehicle. It could be a totally mesh network device between these. It's a fascinating scope here. So a lot of people talk about the edge, but for us, the edge is just, as I say, it's that point between, that thin layer of abstraction between the service and the consumption, irrespective of what that is. So, a lot of people have these sort of slides here. I won't labor the point, but all I can say is there's more coming. Much, much, much more data. And again, lots of people have these sort of slides here. In a second, you can see, and I won't read these off, you can see just the amount and the enormity of the data transfer that's going on over the internet today. So the future's already here, it's just not evenly distributed, as William Gibson famously said in a book several years ago. So let's look at that transformation. So today, given that person has access to an active cell or a satellite structure, that anyone in Africa with a smartphone has access to more processing capacity than the US government did in the 70s, and access to more information than the president did when Clinton was in office. And with 5G, all of these people can now be a global live media broadcaster. So you think live, unscripted television's bad right now, you wait till this happens. It's going to be extraordinary. So all of this relies on the internet. And this is based on, and there's no apologies here, this is based on an American structure here, but that's where it started on the east and west coast, and it's proliferated across. But the internet was designed, it's a non-deterministic technology. So it's designed specifically to be self-healing. So if one node breaks, then it can restructure itself. And this could easily be the flat market in Europe. So this was a wonderful product, a wonderful technology for email and web, where each of the packet structures would go any which way based on the traffic loads of every connection that's connected to at any given time. It's a terrible technology for cloud, mixed reality, virtual reality, and a lot of Internet of Things, and certainly video. It's just dreadful. Now around these structures, obviously as the network grew, and it grew on the basis of predetermined rights based on the telegraphy architectures, then telephony, and then the internet. The internet's just not in enough places. So it's around those main peering zones, and again, this could be the flat market. That's where the data center clusters grew, and then out of that, we had these mega sites grow up, as we have in Grange Castle in Ireland, emerging in the Nordic regions where, again, power is cheap. That's where you see a lot of the hyperscalers and the social media engines building their large-scale architectures. But again, that solves one problem, it's cost. But then as we start using these technologies in anger, then we have more latency issues. And talking about the traffic flows and using them in anger, you can see over the last few years, most of the traffic over the internet is now content. You can see there's a little bit HTTP, a little bit of cloud, the SSL, so it's internet lookup, there's SSL, which is most of the cloud structures, and that's growing year on year. But by far and away, it's downloads to rich media content. And similarly on wireless, it's YouTube, Facebook, and cloud access to the Amazons, the Microsofts, and Googles is growing. And as we start to look even further out, how many of you are familiar with Twitch? Okay, so you've obviously got kids in the house, yeah. So those who don't know Twitch, Twitch started, it was a couple of guys in San Francisco, they built almost like a FaceTime type product where you could share, you could do collaborative work, and very quickly they found the majority of their customers were showing other people how to play games, how to do Minecraft and World of Warcraft and so on and so forth. So they pivoted, and now Twitch is one of the largest broadcasters in the world. At any given time, most internet traffic, contiguous stream data traffic, is Twitch on a global basis outside of China, obviously. They have their own version of Twitch. But this is fascinating. And also, another emerging market is e-games. Just watching games, and also the large, like the annual, what do you call it, esports, beg your pardon, where you have teams of people get together twice a year and compete in doing World of Warcraft or all manner of console games. When that's going on, they have more data traffic than the World Cup, which is extraordinary. There's a whole there's a society, a tribe of individuals just watching this level of content. Now, we changed how we access the internet as well. Do you remember that time where you would go back to your desk to write an email or do something specific, and then you stop going to your desk and you just use your phone? There's a very subtle transition when you made that change, and if anyone can remember that. But the majority of people switched over last year. So earlier in the year here, you can see here that mobile accounts for 59% of all internet traffic. So on some mobile device, either a cell phone or a tablet or a phablet, as opposed to a physical device. And data traffic over mobile is growing exponentially in the States and in Europe here. This is just one chart of many. So as I said, 5G is coming, and that'll just fix everything, surely, because we'll have that huge amount of bandwidth. This is how most people see how we get access to the internet over these mobile devices. You have a device, it hits a tower, either a physical structure or the side of a building, and then goes back to the cloud to get that piece of content, that Facebook like, or that YouTube stream, or that workflow through Salesforce or whatever. In actuality, it hits the antenna, which goes to an aggregation point, a MITSO as it's called, which then goes off to a central office somewhere. And voice and data takes the same path all the way back, way, way deep into the provider's network, before it's then split off to go off and service that media content or that voice call. And those devices, that infrastructure was never designed for that. So in terms of latency, typical latency to RF latency to a device is about 20 to 40 milliseconds. And then it's about 20 to 40 milliseconds on the backbone as well. So when we start looking at 5G, you will have 1 to 4 milliseconds and potentially up to a gigabit of data. It really depends on how it's architected and how it's deployed. But then the back end is still the same. It's still that 20 to 40 milliseconds. So again, we're talking about the edge, we're talking about where the edge needs to be. And in this case, the edge has to be at the base of that cell tower or very, very close to it to then start splitting off that data, either voice and rich media content. So in all these things, Edge is totally dependent upon the service and the consumption. And why it matters? We have this tsunami of data about to hit us, and the infrastructure was never designed for it. So, one of my favorite quotes, an invasion of armies can be resisted, but not an idea whose time has come. Now is the time for the edge. We all have a part to play in that. And I'll hand back to John, we can discuss.